In this chapter, we look back at an addition reaction. Here, we are adding the H and the Br across a double bond. The difference, though, is we have a diene rather than just an alkene. And so we have a couple things that can happen differently. To begin with, you have to do as you would with an alkene and deprotonate the HBr. Okay, now that we've done that, you got to remember positive charge will go on to the more substituted carbon. Okay, so the hydrogen's here. We have the Br minus floating around, and we still have that double bond. Okay, now the thing that we can have happen and we need to consider is the chance of resonance. Okay, so as you can see, we can do a resonance structure and we can form the double bond right there and the positive charge there. Now, you may say, well, that shouldn't be considered because the positive charge now is in a less substituted position. It's primary, and secondary is always better. And that argument is good. However, in this reaction, we are going to consider low temperatures and high temperatures. Low temperatures will be called the kinetic pathway, and high temperatures will be called the thermodynamic pathway. The reason we are going to consider this is because, yes, we have different energies for our intermediates, but we also have different energies for our products. And you're going to figure out which product is more stable in a minute. So first, we are going to now see what happens when the Br minus attacks. Okay, so for this reaction, the Br minus will attack the secondary carbon cation, and we end up getting bromine attached there, hydrogen there, and your alkene in this position. This would be called a 1,2 addition. Now you may say, why 1,2? Well, the hydrogen got placed on the first carbon, and the bromine got placed on the second carbon. And so yes, this went through the more stable intermediate, the more stable carbocation, but when you look at it, it will end up being the less substituted alkene. So this alkene is only mono-substituted. Okay, let's take a look and see what happens when we react the primary carbocation with the Br minus. So now we're going to have Br minus attack the primary location, and you are going to form this product. Okay, this is the 1,4 addition product. And again, why is it 1,4? Hydrogen got placed at the first position, and count how many carbons it took to place the bromine. Okay, so the bromine's on the fourth carbon. So this is 1,4 addition. Now you'll say that the primary carbocation is unstable, and that is true, and it's going to require a lot of energy to overcome that primary carbocation. However, when you look at the product, this is a di-substituted alkene, and the di-substituted alkene will be the more stable alkene of the two choices. Okay, so we have two conditions that we need to consider. Okay, the more substituted carbocation gives you the less substituted alkene, and the less substituted carbocation gives you the more substituted alkene. Okay, so how do we get around this? How do we figure out which reaction is going to take place? It matters with temperature. So as I said, the kinetic pathway will go through a low temperature reaction. So we have our diene, and then we react it with HBr. And in this case, I'm going to say 0 degrees Celsius, which is cold. Okay, and so you're going to end up with a mixture of products, but your major product is going to be the 1, 2. So this is your major product. Okay, and you'll get minor product of the 1, 4. Okay, now if you wanted to get major of the 1, 4, you would have to go through the thermodynamic pathway. And so to do this, we're going to need energy. The energy is going to come from heat. Okay, so anything above room temperature will be something that I would consider adding heat. And so let's say we do 60 degrees Celsius, which is significantly higher than room temperature. And so what you're going to see is that 1, 2 is going to be your minor, and then the 1, 4 will be your major. And this is the reaction or the addition of HBr across a conjugated diene.